Hello everyone. So here I am presenting on the title Good Games for Mathematics Education. And through this presentation, I'm trying to make a case for why games can be useful tools to support mathematics learning. Alright, so this presentation that I prepared is inspired by the 2012 article written by Dr. Valerie Shute and Dr. Feng Ke titled Games, Learning and Assessment, where they talk about game-based learning, explore the potential of games for building complex 21st century skills. They discuss some findings from evidence-based studies that demonstrate this potential of games to impart meaningful learning. And they also discuss how games can be used as tools for assessment by implementing the evidence-centered design model to build assessment activities within the game and game mechanics as actions that players or learners take. Now, from the entire article where all these aspects are discussed, I focused specifically on the seven core elements of good games that the authors identified and synthesized from literature. And I'm trying to make a case for using games in the space of mathematics education by mapping how each of the core element or principle can be used to address concerns with mathematics education, be it concerns due to instructionism based pedagogy of mathematics or due to the complex and abstract nature of the discipline itself. Now, why even is mathematics taught in schools? It is because one of the aims of mathematics education is to impart key life skills like problem solving, critical thinking, rational thinking. All these skills are useful, and mathematics education is a means for building these skills in learner. But did we as students associate mathematics with these skills? Learners rarely associate mathematics with these skills, and failure in mathematics and low achievement associated with students developing a fear of the discipline is common. The situation is so bad that mathematics anxiety is actually a condition, even among adults. And how many times have you heard about something like music anxiety or language anxiety? Now, this anxiety can arise due to pedagogical problems or due to the complex and abstract nature of mathematics, which we will explore a bit in this presentation. Now, moving on to games, why are we talking about games? Well, play is a natural way of learning, and games are natural learning machines. In fact, we all learn something while playing any game, which is the rules of the game. A game is an exceptional tool to learn about complex rules, devise strategies, and solve problems. But when talking about learning games, we refer to games that are intended to build some purposeful or academic knowledge or skills in the player. In his 2005 article, Professor G had also identified 13 principles of games that makes them effective learning tools. Now, the gap in research that I'm trying to explore through my article or through this presentation is the one pointed out by one of the co-authors in this article, Dr. K, in one of her other papers, where they mentioned how the focus of games for learning research has been primarily around improving the effectiveness of games, but not exploring as to how some design principles can be harnessed and used to bridging the gap in learning. All right, so let's dive in. First, we have the principle of interactive problem solving. Now, problem solving is something that is central to both games and mathematics as well. In fact, like I mentioned previously, one of the aims of mathematics education is to inculcate problem solving skills in students. And while in a traditional way of doing mathematics, students are presented with problems that are abstract. For example, asking questions like, is 2 a divisor of 6? Or word problems like, if 6 candies are to be divided between two children, how many would each one get? Games can be actually helpful in achieving some learning goals by providing experiences of interactive problem solving. For example, a game where students are supposed to kill zombies by choosing the right sword. And the relationship between the sword and the zombie could actually be the criteria of division. This was something which was explored by the game Zombie Division by researchers, as we have here on the screen. The second game design element is that of games possessing specific goals and rules. Now I am trying to argue that the discipline of mathematics is all about games and rules. Mathematicians work with a specific set of axioms which are assumed or previously known to be true, and they play around with them to form new knowledge like theorems or to solve problems. These two aspects could actually be mapped onto the rules and the goals through a game. In addition, In order to teach the procedural aspect of mathematics, games can be designed by mapping the problems onto the game goals and the laws onto the game rules. The evidence-centered design, again that we discussed previously, can be a helpful tool to achieve this, breaking down and mapping problems to goals and laws to rules to design games for mathematics. Moving on, providing adaptive challenge is an aspect that can of course help students across disciplines, and adaptive feedback and adaptive and dynamic assessment, as we have seen, is something that is talked about in literature as a key feature to support learning. But in the context of mathematics, where fear and diagnosed conditions like anxiety and dyscalculia are present, adaptive feedback can be particularly useful to support students with specific needs and provide a personalized and customized learning path. Interacting with mathematics learning content at one's own pace without the fear of peer pressure and judgment can be particularly useful for building confidence and alleviating the prevalent fear of mathematics. Now, control. Again, this is something in my experience which is a huge problem with mathematics classroom compared to other disciplines, for example, language, science, arts, where student-centered learning experiences in some form, for example, writing an essay in language class, performing a physical experiment, creating an original piece of art, are common. Mathematics classroom are deep-rooted in teacher-centered pedagogy, where the expert teacher is supposed to provide all correct solutions, or at least supposed to know all the correct solutions. Now, this leaves little or no space for students to take control of their own learning and express creativity, a feature which is rarely associated with school mathematics, but a skill demonstrated by mathematicians. Student agency is something that is completely absent in math classrooms, and games which provide authoring capabilities and multiple ways of approaching a problem and solving a problem can be particularly useful again to promote agency and creativity in mathematics. Now, in addition to adaptive feedback, ongoing continuous feedback by games can also be useful to tackle a common problem with mathematics education, and that is of misconceptions. Because of its complex and abstract nature, misconceptions in mathematics is a common problem leading to low achievement, and misconceptions acquired at an earlier grade can lead to students often developing further misconceptions because, again, coming back to the nature of mathematics, where concepts are built onto each other. The ability of games to dynamically assess and provide adaptive feedback through in-game and out-of-game elements, like glossary videos or in-game pedagogical agents, can be extremely useful for identifying and addressing student misconceptions in mathematics. Digital games collecting player data can provide support and scaffolding in real time to prevent common misconceptions among students. Another problem with mathematics pedagogy has been the continuous emphasis on one correct answer and this mindset of one correct answers. Open-ended questions and multiple approaches to tackling a problem are hardly presented or encouraged. This leads to rigidity of methods and prohibits out-of-box thinking. Again, something which mathematicians use a lot, out-of-box thinking to approach new problems. And through the uncertainty element, good games have the capacity to develop and reward such thinking by designing appropriate game mechanics and scoring systems. For example, the game Refraction provides learning support through its incentive structure and level progression by awarding brain points associated with content-related play performance. So if a student adopts a really innovative or uncommon way of solving a problem, that is not disregarded, in fact, that is actually promoted by the game. And hence, by creating a space for unpredictable solutions, such games encourage multiple ways of problem solving and build crucial mathematical skills. Now, the final element is that of sensory stimuli. Now, it is known that providing multi-sensory learning experiences can lead to rich and deep understanding of concepts. Games for mathematics can particularly leverage this aspect of effective pedagogy by providing real-time depiction and manipulation of mathematical objects. Since there is a lot of translation of mathematical objects from one form to another, for example, an equation in its algebraic form will represent a unique curve in its geometrical form. And the ability of games to allow this translation through different inputs from the player, either by touch or click, and then presenting that information through visuals can help students to build connection between different topics, test and verify hypotheses, and hence construct their own knowledge. This is something which is also common to some educational softwares around mathematics as well, but could easily be translated to math games. So yes, that was my take on the 7 core elements of good games identified by the authors and how they can be used to address specific concerns in mathematics education. I believe that digital games that effectively integrate core principles of game design, aligning game mechanics and player behavior with the theories of learning, can be useful tools to deliver deep mathematics learning and help alleviate the stigma that is associated with the discipline. Of course, a systematic exploration of game attributes that meaningfully address these concerns associated with the complex nature of mathematics and pedagogy is needed. Also, I would urge you all to read the original article by Dr. Shoot and K, the link to which is provided in the description of the video. Thank you for your time. See you later.